Now, tell me the various operation that can be performed on the lathe machine. Anybody, please? What are the various lathe machine operations? Please, anybody?
Facing,
Facing, okay.
drilling,
Drilling,
turning,
forming, yes. Next,
step turning,
step turning, okay, good. Next,
chamfer,
knurling,
chamfering, knurling, okay. Next,
parting
growing,
of,
parting off, okay. Growing,
growing,
correct.
forming,
Forming, okay.
boring, boring,
goring,
Boring,
growing,
exactly. Next,
threading,
threading, exactly. Next,
knurling,
knurling, okay. Are the various operations that can be performed on a lathe machine. Come to the next point. Tell me the various lathe components. Yesterday we already studied the various lathe components. Tell me which are the various lathe components.
carriage,
Carriage,
bed,
bed,
chuck, chuck,
chuck, okay,
tailstock,
tailstock,
headstock,
headstock,
headstock, exactly. We will see one by one. Lathe are equipped with a variety of components as shown in figure. Their basic features and functions are: first one is a bed, second one is a carriage, third one is a headstock, and next is a tailstock, and last one is a feed rod and lead screw. We will study one by one. Tell me what is the function of bed? Why bed is needed in case of lathe machine?
support,
Yes,
to
yes,
support the other parts of lathe.
yes, to support the other parts of lathe. From which material that bed is manufactured?
cast
cast
iron,
iron,
Cast iron. Why cast iron is there? Your answer is correct.
Self-lubricating property.
Self-lubricating property, exactly. Then what is the function of carriage? What is the function of carriage?
provide movement to the tool,
Provide movement to the tool. In which direction? Why movement is required to the tool?
longitudinal,
Longitudinal line. One is the longitudinal, correct, and second one is a longitudinal line. Second is a transversal, that is x-axis and y-axis. For turning purpose, x movement is needed, and for facing purpose, y movement is needed. So for turning and facing purpose, this carriage is used on which that tool is mounted in a tool post. Then tell me what is the function of headstock?
transmit power to the different parts of lathe,
Transmit power. Okay. Again, next. Yes. What is the function of headstock? Tell me where is the workpiece is mounted, or which is the work holding device used in the lathe machine? Yes. लेथ मशीन मध्ये आपण वर्कपीस कुठे फिक्स करतो किंवा माउंट करतो? It is mounted in a chuck, and that chuck is mounted in a
Headstock,
headstock. Exactly. Then what is the function of tailstock? What is the function of tailstock? Yesterday already we discussed.
For drilling purpose and fix the job.
For drilling purpose and hold the job. If job length is more, then to hold the job, tailstock is provided for the supporting through that dead center. Then what is the function of feed rod? Before feed rod, tell me what is the function of lead screw?
It will support the carriage
Yes?
to move forward and reverse.
No, please repeat. Please
Lead
repeat.
screw supports carriage to move forward.
Yes, during that operation. And what about feed screw?
Feed screw is used to while in operation.
In operating? When we are doing that threading operation, then pitch is very important, and for that pitch purpose we are giving auto feed, and for that auto feed we are doing some calculations are there for gear calculations, and through that gear calculation we are placing the gears, and for exact feed, or I will say for exact pitch, we are using feed screw for auto feed purpose. Here one video which shows the various lathe components. I will play here. Hello, is was the video clear? Hello, video clear होता का रे? Hello, please anybody? Video was clear? Pallavi, video was clear? Hello, hello Pallavi. Hemant is there? Hello, anybody? Pallavi? Hello?
हाँ सर होता सर
होता ना? Okay. Then tell me apart from that previous parts or including that previous parts, tell me the various parts which are used to manufacture a lathe or to build a lathe. Anybody? Tell me the total parts. We will discuss the total parts one by one to build or to manufacture a lathe machine. One by one, please. Please, one by one. Tell me number of parts which are used to build a lathe machine.
Bed,
Bed, okay. Next,
tailstock, headstock,
okay.
tool post,
Okay. What is the function
Chuck.
of what is the function of tool post? What is the function of tool post?
Hold the tool.
Hold the tool, okay. Then next,
Chakki.
yes,
Chuck.
chuck, okay. What is the function of chuck?
spindle,
Yes,
spindle,
Hold the workpiece.
okay, okay. Spindle for rotation purpose. Okay, then next,
Feed rod,
feed rod, okay. Then next,
hand wheel
and we'll okay. We are not interested to that minor parts. We are interested in the major parts.
Apron.
Yes, apron, exactly. Then
Coolant.
coolant is not used in most of the cases. It is used for that CNC machines.
saddle,
Saddle, exactly. But saddle is right now normally it is okay for lathe machine, but it is plays major role in a VMC machines for movement of X and Y. Okay, then your saddle plays
Gears.
yes,
Gears.
gears. What is the function of gear in a lathe machine? What is the function of gears in a lathe machine?
to control speed,
To control speed, or in case of threading operation, when we are doing threading operation, last time I already told that when we are doing that threading operation, pitch is a very important, and for controlling pitch, manual feed is not necessary. Manual feed is not work there. So in that case, auto feed is required, and for auto feed, we are using uh, that feed rod for that purpose. Now come to the next point: work holding devices and accessories. Tell me which are the various work holding devices in the lathe machine? Anybody? Which are the various work holding devices used for lathe machine? Does anybody?
chuck,
Chuck. Okay. What is the function of chuck?
to hold the workpiece,
Okay, but okay, it is to hold the workpiece, chuck is used. What are the types of chucks? Anybody knows?
3-jaw and 4-jaw.
four jaw.
Exactly. What do you understand by self-centering chuck and independent chuck? Anybody who completed diploma? Yes, what is a self-centering check and what is independent check? Considering that example of 3 and 4 ja, 3 check is called as a self-centering check and 4 check is called as an independent check. Then self-centering check, what do you understand by self-centering check? When you are rotating that check, all 3 jaws come together. हे तिन्ही जॉ एकत्र आत येतात किंवा एकत्र बाहेर जातात. That is called as a self-centering. Yes, normally it is used for round jaws. And when independent check, 4 check is called as an independent check. It is used when other than round shape, that is rectangular shape or square shape is there. In that such type, that rectangular check, 4 check is used. म्हणजे इंडिपेंडंट चेक मध्ये एका वेळी एकच जॉब आत बाहेर होणार, त्यामुळे आपल्याला इरेग्युलर शेपचे जॉब असतील ते पकडण्यासाठी त्याचा उपयोग होतो. ओके, apart from chuck, again tell me which are the various work holding devices. Can I manufacture or can I do turning or facing operation of irregular shape component? ज्या कंपोनंटचा शेपच इरेग्युलर आहे त्या जॉबचं मी फेसिंग ऑपरेशन किंवा टर्निंग ऑपरेशन करू शकतो का? Normally facing operation. Can I do facing operation of the same? Yes, we can do facing operation of irregular shape by using face plates. मी आता पुढे दाखवतो तुम्हाला. Work holding devices and accessories. Work holding devices are important as they must hold the workpiece securely. In a place. Work holding devices are important as they must hold the workpiece securely in a place. त्याच्या पर्टिक्युलर प्लेसला ते वर्क होल्ड करतात. That's why work holding devices are important. As shown in figure, one end of the workpiece is clamped to the spindle of the lathe by chuck or collet or faceplate or mandrel. We'll see one by one. This is a example of chuck. We will not going to draw this figure because some critical drawings are there, so we will not waste time here. This is called as a 3-jaw chuck. Right now, your chuck is shown here. This is a chuck. And these are the jaws. 1, 2, and here 3rd jaw is there. This is a workpiece. This is a diameter. D naught, that is outer diameter. DF is there. Then D, depth of cut is there. Tool is there and feed is there. Question to all: what do you understand by feed in a lathe machine or any machining operation? What do you understand by feed? And what is the symbol of feed? Those who are completed diploma, tell me what do you understand by feed and what is the symbol or what is unit for feed?
Force.
Yes?
Force.
No, feed is not force. Feed, the unit of feed is mm per revolution. Tell me what do you understand by then feed. Suppose feed is a 0.1 mm per revolution, means
Depth.
yes? मी सांगतो तुम्हाला फीड म्हणजे काय. फीड इज नथिंग बट mm per revolution. Normally it is given 0.1, 0.2 mm per revolution. It depends on our workpiece material, tool material and machine condition. Suppose feed is a 0.1 mm per revolution means that this tool is advantages. म्हणजे इकडे तुमचं टूल मूव्ह होणार आहे. जेव्हा एक कंप्लीट रिव्होल्यूशन होणार तेव्हा टूल किती मूव्ह होणार आहे? 0.1. Because I am given feed 0.1 mm per revolution. When I rotate this one revolution, tool advantages by 0.1 mm. म्हणजे mm per revolution 0.1 mm per revolution. याच्या एका रिव्होल्युशनला टूल माझं 0.1 mm पुढे जाणार आहे. दिस इज कॉल्ड एज अ फीड. It is one of the work holding device. Chuck is the one of the work holding device. Coming to the next, collet. Here, hairstock spindle sleeve is there. Then spindle nose cap is there. Here, spring collet sleeve is there, in which spring collet is fixed. म्हणजे आता this is a spring collet is fixed here, and when you want to hold this component in a collet, because one video is there, after that one video is there which clear which are the work holding devices used for lathe machine. Just go through this sketch. If it is unclear, then it will be cleared in the sketch itself, no problem. So here stock spindle sleeve is there, then spring collet is there, and in a spring collet that workpiece is hold to manufacture or to do the various operations. Again here this is a workpiece shown here. This is a collet, and in a collet this is a collet, and in a collet workpiece is fixed. In this collet workpiece is fixed, and when we are spindle nose cap is there, when we clamp it, here serrations are there. म्हणजे जेव्हा मी फोर्स अप्लाय करणार त्या serrations मुळे काय होतात, हे जॉ आत येतात जॉ, आणि या जॉ मध्ये काय आहे, माझं वर्कपीस आहे इथे दाखवलेलं आहे तुम्हाला. त्या जॉ मध्ये काय आहे, मी वर्कपीस फिक्स केलेला आहे, आणि इथे जे स्लिटिंग दाखवलेलं आहे आणि वरनं तुम्ही आवळणार, या स्लिटिंग मध्ये काय होणार आहे, जॉब क्लॅम्प होणार आहे. त्याच्या स्लिटिंग मुळे जॉब क्लॅम्प होणार आहे. दिस इज सेकंड सेम कॉलेट टाईप, अँड अनदर टाईप ऑफ कॉलेट इज देअर. म्हणजे तुमचं जर का कंटिन्युअस फीड येणार असेल स्पिंडल कडनं, तर त्या केसमध्ये इथे स्पिंडल इज देअर, वूड इज देअर, अँड कॉलेट इज देअर. Collet clamp, declamp is taken place. When declamp is there, workpiece is moved for machining purpose. Again through hood, again it is clamped. Once the operation is completed, through hood it is again declamped. Workpiece comes again forward. So continuous work, there is a continuous movement of workpiece takes place. Workpiece तुमचा कंटिन्यू पुढे येतोय मशीनिंग साठी. In that case, this work holding device is used. Again फेस प्लेट, I already told that if irregular shape is there. तुम्ही आता जसं लेथ मशीन मध्ये मला सांगा स्पिंडलवर चेक कसा फिक्स करताय रे. हाऊ दॅट स्पिंडल इज फिक्स्ड ऑन चक, सॉरी चक इज फिक्स्ड ऑन स्पिंडल. हाऊ द चक इज फिक्स्ड ऑन स्पिंडल, प्लीज एनीबडी. Actually स्पिंडलला थ्रेडिंग असतात, थ्रेड्स आर देअर, आणि इन दॅट थ्रेड्स, आणि चकला पण थ्रेड्स असतात, आणि त्या थ्रेडमध्ये आपण चक फिक्स करतो. स्पिंडल देयर इज एक्सटर्नल थ्रेड्स आर देअर, अँड फॉर चक देयर आर इंटरनल थ्रेड्स आर देअर, अँड थ्रू दॅट जस्ट लाईक अ नट अँड बोल्ट असेंबली, स्पिंडलच्या आउटला जे एक्सटर्नल थ्रेड आहेत त्यामध्ये आपण चकचे इंटरनल थ्रेड फिक्स करतो. देन फेस प्लेट इज अगेन वन ऑफ द मेजर वर्क होल्डिंग डिवाइस. मी काय करणार, चक काढणार आणि फेस प्लेट आहे असे फिक्स करणार. दिस इज अ फेस प्लेट, अँड फॉर फेस प्लेट देयर इज अ थ्रेडिंग इज देअर, आणि ते थ्रेडिंग स्पिंडलच्या जे एक्सटर्नल थ्रेड आहेत त्याला जाऊन फिक्स होणार, माउंटेड ऑन अ स्पिंडल. अँड दिस इज अ टर्न सरफेस, फेस सरफेस, वर्कपीस इज देअर. दिस इज फेसिंग ऑपरेशन, दिस इज टर्निंग ऑपरेशन. द ॲडव्हान्टेज ऑफ दिस इज दॅट इरेग्युलर शेप्स, म्हणजे आपले जे इरेग्युलर शेप्स आहेत, रेक्टँग्युलर असेल, वेगवेगळे शेप्स असतील, त्याला आपल्याला फेसिंग वगैरे किंवा टर्निंग ऑपरेशन करायचं असेल तर आपण फेस प्लेट यूज करतो. ज्या फेस प्लेटमध्ये आता इथं त्यांनी दाखवलेलं आहे, क्लॅम्पिंग दाखवलेलं आहे, त्या फेस प्लेटला मागं स्पिंडलमध्ये फिक्स करतो, आणि फेस प्लेट इज जस्ट लाईक अ फिक्चर वर्क होल्डिंग डिवाइस which is clamped through it. It is a work holding device which is used for various operations. Here I will show one video of this same, then I will come back to the again various work holding devices.
The most commonly used work-holding device for the lathe is the chuck. Chucks come in two varieties, universal and independent, and can have 2, 3, 4, or 6 jaws. Collets are also very commonly used for their speed and accuracy. Universal chucks are chucks where all the jaws move at the same time when the key is turned. They're excellent for being able to chuck a wide variety of diameters quickly. However, they will never clamp in the same place twice. This means if you machine a diameter, take the part out and rechuck it, and then machine the second side at the exact same crossfeed setting, your two cuts will not be concentric to each other. Hopefully you can see on camera that there's a significant step right there in the middle. On even the best quality chucks, the most accuracy you can hope for with universal chucks is around 0.03 of an inch runout. Runout is defined as the deviation from the actual center line of the lathe spindle, and that's expressed as total indicated runout, or TIR, meaning the deviation from either side of center line. For example, 15 thousandths TIR would be a deviation of 7.5 thousandths on one side or the other. It's not uncommon for cheaper chucks and old worn-out chucks to have a lot more runout than just 3 thousandths. As long as you know this limitation, though, you can work around it, doing all of your machining in one setup. If your part has loose concentricity tolerances, or none at all, then universal chucks are generally the fastest method of work holding for the lathe. Universal chucks are available in 2, 3, 4, or 6 jaws, with 3 and 6 being the most common. Independent chucks are chucks where each jaw can be moved individually via its own screw. This allows you to dial a part in to any degree of concentricity that's required. With a little practice, you can very easily attain 0.5 thousandth total indicated runout within a couple of minutes. Since each jaw moves independently of the others, you can also use these chucks to hold parts eccentrically, for instance when you're machining a cam. Independent chucks are most often 4-jaw chucks, so they can be used for machining square and rectangular stock as well. The main limitation for these chucks is speed. They're somewhat labor-intensive to set up, and they have to be dialed in every single time a part is chucked. By far, at least in the United States, the most commonly used type of collet used on the lathe is the 5C collet. 5C collets are available to hold round, hex, and square stock, and have a round capacity from 1/32 of an inch up to 1 1/8. Machinable collets are also available for making special fixtures or sizes that are not commonly available. 5C collets are very accurate, generally holding within 0.5 thousandth of total indicated runout, and they're very quick to use on multiple parts of the same diameter. Collets can also be outfitted with stops, so multiple identical parts can be machined quickly without having to establish a reference surface for each part. On the downside, they have a limited clamping range of only about 0.5 thousandths of an inch, so the part must be very close in size to the collet diameter, and it also takes time to change collets so different diameters can be held. There are other types of collets available to use on lathes that have either different holding styles or larger or smaller capacities, but 5C collets are the most widely used by a very large margin. In addition to these work holding methods, one can also bolt large irregular workpieces like castings and forgings directly to a faceplate, which is a flat plate with slots for mounting bolts. When placing your part on the faceplate, you get it roughly centered using the concentric rings machined into the face. Faceplate work is generally off balance when the lathe is running, so care should be taken to either place counterweights on the opposite side of the faceplate to balance the load, or just run the lathe slowly. Turning between centers entails having a center in both the headstock and the tailstock, and the workpiece is driven by a lathe dog, which is bolted to the part and has a tail that rides against either a chuck jaw or one of the slots on a faceplate. The part will have a center hole drilled in each end. The advantage of turning between centers is that the part can be removed again and again, and the centers will always locate it back to the lathe axis, ensuring that the part is concentric. Turning between centers can also be used to turn tapers by purposely offsetting the tailstock one direction or the other. That'll be the subject of a future video. Turning between centers is not done very much anymore. It used to be a lot more widespread, but there are some very notable uses for it, such as turning electric motor shafts. All of those things, the bearing journals, the rotor of the motor itself, all have to be concentric, so turning between centers is a fantastic way of doing that. It's also a very good way of cutting multiple start threads. You can put your part in there, cut one thread while it's bearing against one of the chuck jaws, then take your part out, make it bear against the next chuck jaw, and cut the thread again, and then at that point you just move it to the next chuck jaw and cut your last thread, and you end up with triple starts. You could of course use a 4-jaw or a 6-jaw to get more options on the number of starts. The textbook method of turning between centers involves putting a center in the spindle of the machine. You would then install your faceplate and drive the lathe dog using the slots in the faceplate. Of course, my lathe dog doesn't actually fit inside these slots, but ignore that, okay? A much simpler method is to just put a piece of scrap steel in your chuck and angle your compound to 30 degrees, then use that to cut a center point onto that piece of scrap. The point is guaranteed to be concentric to the center line of the spindle, and the part can be installed onto the new center and just driven off of the jaws of the chuck. The piece of scrap can then just be put into your toolbox when you're not using it, and anytime you put it back in, just be aware that you'll need to recut the point to make sure that it's concentric with the lathe axis. This can just be a skim cut since you've already got most of the material already removed, so it doesn't take very long to touch it up at all. When you're changing out chucks, you really want to do something to protect the ways of the machine. These are the precision surfaces, and you don't want them getting dinged up if the chuck should fall. Chucks can be very heavy, so it's a good idea to take a piece of plywood and put it down on the ways in case the chuck should fall when you're taking it off. It's also a good idea to have 2 hands on it at all times in case it should get away from you. This is a threaded spindle, but there are multiple different methods of attaching a chuck to the lathe spindle, such as cam locks or the long taper spindles. Regardless of how the chuck attaches to the spindle, you really want to make sure that everything is nice and clean, especially on a threaded spindle. You don't want any chips on the inside of the threads that could potentially cause concentricity errors. Likewise, you want to make sure that every mating surface on the chuck is clean as well. Again, especially on threaded spindles where those chips can get all inside and cause a lot of problems. Before we move on to the tool portion of this video, I'm trying to clear up a little something and I'm hoping you guys can help. I have 2 dogs, Iggy and Chacho, and I can't figure out which one's cuter. I figure I can get your help by having you guys vote on it. To vote for Iggy, press the like button down below. If you'd rather vote for Chacho, hit that subscribe button instead. If you can't decide between the two, just go ahead and hit them both. Tools can be held in either the tool post or the tailstock. The vast majority of tooling will be held in the tool post, and you can do a wide variety of operations on the lathe. Quick change tool posts are widely used in industry because multiple tools can be set up on center and ready to use. Each tool is held in its own holder which mates to the tool post. The holders all have adjusting screws to set the center height of the tool. The holders are changed out by loosening a cam on the tool post and sliding one holder off and the next one on, which greatly increases productivity on jobs that require multiple tools. I have a video specifically about quick change tool posts, and I'm going to put a card right here linking to that video. Like I said, there are a lot of different types of operations that you can perform on the lathe. Facing is cutting on the end of the workpiece to produce a flat end or cut pieces to length. Turning is cutting on the diameter of the workpiece. Boring is just like turning, except it's on the inside of a hole, and it enlarges the diameter. This, of course, requires pre-drilling. Threading is used for cutting screw threads, either externally or internally. Knurling is an operation that produces a surface that can easily be gripped as a handle, and the knurl can be straight, angled, or diamond-shaped. Knurling usually displaces metal rather than cutting it, although cut knurling tools do exist. Grooving is used for cutting recesses for O-rings or retaining rings. This can be either exterior or interior, or actually on the face as well. Parting is used to cut a part off from the rest of the stock. You should always use plenty of oil when you're parting, and in general I try to feed by hand so I've got a sense of feel while I'm doing it. That way you can really tell what the tool is doing. If the part's hollow like this one, I usually try to catch the part on a piece of stock or a screwdriver. You can hold it in the drill chuck if you need to. And that way it doesn't go dinging off the ways or flying off into the ether after it releases from the parent stock. The tailstock can hold a multitude of different taper shank tools, such as drill chucks, taper shank drills, reamers, and counter bores, and all sorts of different centers. You have your regular type of live center, as well as the extended point or CNC point, which I really like because it gives you a lot of extra tool clearance at the end. And then you have the bullnose center, which is used for supporting pipe and large diameter tubing. All of these tools have Morse tapers, which is a self-holding taper. To seat it, you just give it a firm smack into the tailstock quill and it'll hold just fine. In addition to live centers, there are also dead centers, which do not rotate. They're just a solid chunk of steel, whereas the live center rotates with the workpiece. Dead centers are really not used very much anymore. Nowadays, they're mostly used in the headstock when you're turning between centers. They're also sometimes used on the mill to support a longer workpiece when you're using a dividing head. I hope you found this video helpful. If you have any questions, please leave them down in the comments. Don't forget to cast your votes for Chacho using the subscribe button, or Iggy using the like button. Thanks for watching, and I'll see you next time.
Yes, it is clear that various work holding devices. Does anybody? It is clear that various work holding devices, that is chuck, then collet, then faceplate. It is clear? Is anybody? It is clear or not with the various work holding devices? Hello? Hello? Okay. Please give me attendance. Roll number 1 to 10.
8.
Hello?
Hello.
Roll number 1 to
8.
10. 8, okay. 11 to 20.
14.
Hello.
14.
Sir, 8.
15.
Sir, 8.
8 is there. 14, 15,
17.
17. 21 to 30.
25.
28.
27.
Okay. 31 to 40.
35.
34.
41 to 50.
46.
Okay. 51 to 60.
55.
61 to 70.
66.
71 to 80.
Sir, 66.
66. Okay. 71 to 80. 81 onwards. Okay. Thank you.
Sir, 55.
55. Okay. Okay. Thank you.